Question number 31. Consider the dipole moments of the given compound. So we have been given three different compounds. First is the benzaldehyde, second is chlorobenzene, and third is aniline. So in which of the given compounds the direction of the dipole moment is towards the benzene ring? So if you look very carefully at the groups which are given to your students, the CHO, it exerts a -I and -M. So the direction of the dipole will be towards the CHO group. If we talk about the second compound now, we have chlorobenzene. So chlorobenzene exerts a -I and a +M. But we know that -I is more than +M for this case. So it is again withdrawing in nature. So the dipole will be oriented along Cl. If we talk about aniline, students, in aniline, the lone pairs of nitrogen are very strong. They exert a very strong +M effect, which dominates the -I by the nitrogen. So in this case, the direction of the dipole will be towards the benzene ring. So students, out of these given compounds, only in the third compound, the direction of dipole moment is towards the benzene ring. So for question number 31, we have to mark the correct answer as option 4. Let us look at the next question now. Question number 32. For an endothermic reaction which proceeds with an increase in entropy, the plot of ln K equilibrium versus 1 by T has. So if we talk about the relation between ln K equilibrium and delta H and delta S, students, we can have ln of K equilibrium is equal to minus delta H by R into 1 by T plus delta S by R. So students, we can clearly see that this is a straight line. So we have Y, this is X. So this has to be the slope and this has to be the intercept. So the slope value is given by minus of delta H by R, and since the reaction is endothermic, students, the delta H value will be positive. So if we talk about the slope will come out to be negative. And if we talk about delta S now, students, so delta S, it is mentioned to us that the reaction proceeds with an increase in entropy, so the delta S has to be positive. Students, the delta S by R will also be positive and the intercept will come out to be positive. Okay. So the given plot is going to have a negative slope and a positive intercept. So if you look at the options which are given to students, we can clearly see that for this question, we have to mark the correct answer as option 4. Let us look at the next question now. Question number 33. In which of the given transitions the change in angular momentum of the electron is maximum? So students, we know that the angular momentum, it is represented by the letter L. So students, we know that L is equal to mvr, which is equal to nh upon 2 pi. So we can clearly see that, students, the L value is directly proportional to n only, since h and pi are constant, students. So L is proportional to n. It means that delta L will be proportional to delta n. So that transition in which the change in the principal quantum number is the maximum is going to have the maximum change in angular momentum irrespective of the atomic number Z. So if you look at the options which are given to students, we can clearly see that delta N is maximum in the fourth option, and for this question we have to mark the correct answer as option 4. Let us look at the next question now. Question number 34. Dalton's law of partial pressure is applicable for which of the following pair of gases? So if we talk about Dalton's law of partial pressure, students, it is applicable to gases which do not react. So it is applicable to a mixture of non-reactive gases. So the gases which do not react with each other. So if we look at the options which are given to students, H2 and He will not react with each other. So this will be the answer, students. If we talk about ammonia and carbon dioxide, ammonia is basic whereas carbon dioxide is acidic, so they will react, students. If we talk about ammonia and HCl, it is a similar case, acid-base reaction. Ammonia is a base, HCl is an acid, they will react. And if we talk about H2 and F2, students, they also react to form HF. So the Dalton's law of partial pressure will not be applicable for the mixture given in option 2, option 3 and option 4. And students, for this question, we have to mark the correct answer as option 1. Let us look at the next question now. Question number 35. Which of the following plots represent the intensity versus the wavelength of emitted radiation for a black body at two different temperatures, T1 and T2? Okay. So students, if we talk about the intensity of the black body radiation, we know that as the temperature increases, the intensity will increase. And if we talk about the intensity maxima, students, the maxima for intensity will occur at a smaller wavelength. Okay. So if this was the plot at temperature T1, students, Then if we talk about the temperature T2 where T2 is more than T1, so the peak is going to be higher and the peak will also be shifted towards the left. So this will be the plot at the temperature T2. And if you look at the options which are given to us, students, we can clearly see that for this question, we have to mark the correct answer as option 2. Let us look at the next question now.